Alright, let's start with something simple. Section 4.1 is definitions of terminology and terms that we use over and over again in this chapter, later on chapters, the rest of the course, and frankly, the rest of your career as electrical engineering as well. So pretty fundamental terms we are going to define in simple definitions. And then in the next video, I'll provide you a simple example. All right, so the terms that we are going to look at are node, let's see, node. This is a pretty important concept that we are going to look at. Then we'll discuss what an essential node is. Okay, so let's call this 1, let's call this 2. So we're going to look at the definition of a path. Okay, and then we'll define a branch. And then hand in hand with the definition of branch, we'll define an essential branch. Okay, so we'll define an essential branch. Then we'll talk about a loop and a mesh. Okay, some pretty simple definitions, and these are available in the textbook as well, but we will discuss these. So first of all, what is a node? A node is simply nothing but a point where two or more circuit elements join. Okay, so node is where two or more let's see, circuit elements join. Okay, so this is where two or more circuit elements join. Now let us see what is an essential node. Well, an essential node is a node where three or more circuit elements join. Okay, so what I'm going to do is to copy all of this, duplicate this essentially. So an essential node is really a node. Okay, is a node where three or more circuit elements join. Okay, so that's you see the idea? An essential node is a node where three or more circuit elements join. Okay, now let's look at what a path means. What a path really means is a trace of adjoining basic circuit elements with no elements included more than once. Okay, so that's the textbook definition. A path really is when you have a bunch of different basic circuit elements. Okay, you can start at any one particular element and trace a path of current. Okay, trace a path of adjoining basic circuit elements. So when they are next to each other, okay, and with no elements included more than once. Okay, so you can call that a particular path. Okay, the path that a current flows. Now, quick definition: it's a trace or a path followed, trace of adjacent, really adjoining circuit elements where you are not following through a circuit element a second time. Okay, I'm going to show that with an example. Now, what is a branch? So a path, we know a path, what a path is. It's simply a trace or a path that current takes into adjoining elements, and then you are not including the same element twice. Okay, each element included once if you're following a particular route, that is called a path. Okay, now what is a branch? A branch is nothing but a path between two, okay, nodes. Now let's say, what is a node? Remember, um, a node is nothing but um, a point where two or more, okay, where two or more circuit elements meet. Okay, so this is a node, this is a node, this is a node. Now what we call as branch is the path between two nodes. Here is a node and here is a node. The path between that is called a branch. Okay, the same thing here. You see, there is a node right here, there is another node right here, and the path or the connection between these two nodes, okay, this node and this node, the path in between them is called a branch as well. Okay, so a branch, the formal definition of branch is a path between two nodes. Okay, now let's say path between two particular nodes is called a branch. Now an essential branch is something similar in spirit. It is a branch, essential branch. It is a path that connects two essential nodes. So, okay, it should connect two essential nodes, and it should not have another essential node in between. Okay, so a path is an essential an essential branch is a path between two adjoining essential nodes. Okay, now a loop, this is another definition that we will use over and over again. A loop is a path where last node is the same as the starting node. That's what the textbook says. A path that begins and ends on the same node. Okay, a path that begins, a path that begins and ends at the same node. So in other words, you start at a particular place, you go through all the destinations that you want to go through, and you return to the same point where you started from. Okay, that's called a loop, a closed path, a round trip of multi-point, multi-city round trip. You can think of it that way, and I'm going to show that to you using an example. Okay, now the last definition that we want to show is or discuss is a mesh. A mesh is a loop. Okay, remember what a loop is? A loop is a closed path. Okay, simply put, a loop is a closed path, a path that begins and ends at the same node. Now, a mesh is a loop that does not enclose any other loop. Okay. Now, all of these definitions, they may see a bit hazy right now, but when we look at an example, okay, when we see an example, this is going to be much more straightforward. Okay, and it is very important that we understand these definitions. Don't worry if they're a little hazy now. Right now, in the next video, we are going to go into the example of all the definitions. That will make things much clearer. All right, see you in the example problem.